Welcome to data science, and this is the introduction to R and also RStudio. There's a couple of sections in this. We're going to talk about the R programming language and a little bit about using R and some R basics. So, first of all, the R programming language is considered to be the language of data science. But why is it called R? Why is it not called, I don't know, D or C or L or, well, there's already a C. So C was taken, but D wasn't. Now, R is a programming language for statistical computing and graphics, and it's supported by the R Foundation. And it's widely used among statisticians and data miners for developing statistical software and data analysis. And as of November 2020, and I can actually tell you as of January 2021, R ranks 9th on the TIOBE index as a measure of the popularity of programming languages. Now, there's lots of different indexes and ways of measuring things. This is just one of them. So we jump over and have a look at the TIOBE index here for January 2021. We can see that we have the number one language is the C programming language, okay? And this has swapped places recently with Java. That's down in popularity by about 5%, okay? Then we have everyone's favorite, Python, at number 3. Then some other languages, C++ and C#, which are often used for games, Visual Basic, that's used for Windows scripts and things, JavaScript and PHP that are used in web, and then R, which we're using today. So R has actually climbed from 18th most popular language last year in January to the 9th most popular language today. And you'll see within the top 10, maybe even within the top 20, R is the biggest climber. Okay, so definitely on the uptrend at the moment. Now, if we go down and have a wee look at this graph here, we can hover over each of these languages and we can see which ones are popular. So if we have a look at Visual Basic, you can see that that's got a kind of steady little growth, and R is quite similar to that. Look at R. R in 2008 was very low, and then it's just slowly climbing up in popularity. And then if we look at something like Java, okay, we can see that the trend in Java is that it's actually decreasing in popularity. Let's have a look at C. C seems fairly steady, and Python, we can see that this green line, a little bit of a difficult color to see, but since 2018, Python has had an upturn in popularity. So there's R there. Now, the reason that R is probably not as popular as some of these other languages up here is because R is only really used for statistics and data science. It's a special purpose language. Okay, so why R? Right, so there was an old language for statistics called S, okay, and this was inspired by another language called Scheme, and it was created in the 70s. So R was created in the 90s by two people whose first name initial was R. That's Ross and Robert here. So as a sort of play on words for the letter S, they decided to call it R. So that's why it's called R. Okay, so what's RStudio? RStudio is the IDE, the development environment for R. So hopefully in lab 1, we'll have a look at this, and it's fairly simple and intuitive. It's designed to be easy to use, and we have these kind of 4 windows by default: the script window or the source window, the terminal, plots and files and packages, and an environment history window there. So I'll provide a little demo of this just shortly. So before we look into R and RStudio, let's have a look at some basics of the R programming language. So the first thing to think about when we think about R is that everything in R is an object. Okay, so basic R object types are character. Now, character is similar to like a string in Python or in some other languages. Numeric can either be an integer or a float, and logical is like a bool type, true or false. Now, each of these types can be examined with the following function. So we can check what type of object something is using typeof, and we can check how long an object is using the length function. So we just provide the typeof function, and then in here we put what we want the type of, same with length. Okay, so assigning variables can be done with this sort of arrow symbol, or we can use equals, just like we use in Python. Okay, equals or that kind of arrow in are both applicable. So similar to other programming languages, we have some arithmetic operators. So here I've got addition, subtraction, and multiplication are just the normal symbols for addition, subtraction, multiplication. Division, we have the kind of slash symbol. Exponents or powers are done with the hat symbol or the caret, and modulus is done with a double percentage to work out the modulus. Right, relational operators, we have less than, greater than or equal to, less than or equal to is a double equal sign, and not equals to is the exclamation and then equals. Okay, so those are just some of the absolute basics with R. Now, I can actually open a terminal on my computer here, and I can put in a capital R, and this will give me an R console. Okay, so if I wanted to say to R x is equal to 5, okay, and then I say x, R will tell me back 5. And the command to clear the screen in R, this is just a little bonus, this is probably not that important, is actually Control L will clear the screen. I don't know what the significance of the L is. I guess maybe less or lift the pointer. So, and if we do X, we can see that we've assigned X to 5. So if we did X plus 6, that would give us 11 because X is 5. Okay, so this would be incredibly boring if we just had to spend our days typing into a green terminal. So luckily we have RStudio to use. So let's have a look at some vectors in R. Now, the way to think of a vector in R, it's the simplest type of data structure. And if you're coming from a background in some other programming languages, you can think of it, this is similar to an array or similar to a list. And if you're new to programming languages, then you can think of this as just a collection, a way of gathering some data in some object type. So the simplest type of data structure, and the vector is a sequence of data elements of the same basic type. So here we have a vector, okay, that has the numbers 2, 3, and 5 in it. Okay, and if we were to call the vector, this is what R would send us back, those numbers. Here, down here is an example of a vector with some Boolean values in it. Okay. We can create vectors using the C function. Now, C actually stands for concatenate. Technically, it doesn't create vectors, it just combines them. So this little graphic down here, you might see online if you're looking for R graphics, and it's got a vector called X, and we're going to use the assignment operator, the concatenate, and then in brackets, we're going to say what's in the vector. So let's say we want to get R installed. Now, as part of lab 1, this is what you'll do. So before I start showing examples, I'll just give a quick overview if anyone's having trouble doing the installation. So the first thing we need to do is download R. And we can do that from the CRAN R project. We can download for Linux, for Mac, or for Windows. And once we've done that, that will give us this facility. Okay, that will give us this command line R base. This is called the R base. Okay, it's the base for R. So what this means is this computer here that I'm using right now is capable of interpreting R. It's capable of running the R programming language. It has that knowledge built in. So that's all well and good if we're happy to just type into the command line. If this was a server or something, that might be fine. But in order to develop our R scripts, we should download from RStudio.com the IDE for R, the development environment, okay? And this has a lot of integrated tools to make writing R a little bit easier. Now, when you go to products and download, you want to download RStudio. You should see this sort of overlay here. The one you want is RStudio Desktop, okay? Now, today, I'm actually using RStudio Server, but they look exactly the same, okay? So once you've downloaded and installed that, that'll be able to work and run the R base in the background, and that'll give you a front end to do development in R. So it should look like this when you've installed it. However, if we go to global options and appearance, yours will probably look more like this white font here. So I usually change the theme to Dracula or to Chaos, just because I prefer working with light text on a dark background. But there's lots of different themes in there depending on what it is you're looking for. So we'll leave it on my choice, which is Dracula. Now, interestingly, I showed you before that there were 4 different windows, but when you first start R, you might think, well, there's only 3 windows here. Where's the 4th one? What we have to do is just go to File, New File, and R Script, and this will open up the script pane there, and then we'll have all 4 of them. Now, down here, all right, if I do x equals 3, okay, this is a similar, this is exactly the same as what I was doing before in the console, okay? And up here we have the environment history saving, and any plots or anything we do will be down here. And there's also some tutorials built in here and some help built in here. Okay, so all of this is explained in detail in the first lab. Okay, so now that we have R installed, we might want to look at running some basic examples. So here we have a vector called fruits, and we're going to create that. We're going to assign this value to it. We're going to create, and in there we're going to put 3 different character items, and those are going to be apple, oranges, and banana. And let's see an example. If we run fruits, it'll print them all out. If we run fruits with a square bracket of 2, it'll give us, it'll actually add this into the second place there. So you can see we've changed the second value there to strawberries. Okay, so a few more R examples to put into practice. So let's have a look at some actual examples. And once we've kind of learned how to apply these in lab 1, lab 2 goes into a little bit more detail in this. So the most basic example we're going to do is we're going to create a plot. Okay, and the plot command or the plot function will take one argument or several arguments in here, and it will produce a plot looking like this. So if we had a vector called cars that we created with the character, the concatenate character with these numbers in it, we could simply run the plot function and pass in this variable here, and R would be able to plot that there. Now that's not a particularly exciting graph there, so let's move on to more plots. So let's say we had something a bit more detailed, okay? We've got our cars vector with some numbers in it. This time we're going to plot, okay? And we're going to say that we want the color to be blue, and we're going to put an overlay, okay? And this time what we've got is a line joining these up. And we can also add another command below with a title. Okay, title main equals autos. It will automatically put the title up at the top there. Color main equals red. Okay, we can specify that. Now there's a list of R colors I can make available to you. Things like dark red, medium blue, medium red. There's all sorts in there. I think we can also just provide a hex code in there as well. Okay, so here's a bit more detail added to that plot. So at the moment we have two vectors now, two numeric vectors, cars and trucks. Okay, and what we're going to do is we're going to plot cars, then we're going to plot trucks, and it's going to give us these two lines kind of intertwining here. And although this is a very simple example, this actually shows us some of the stuff we can do with just a few lines in R. So a different type of plot is called a histogram, okay? This is a histogram here. Okay, so again, defining a simple vector here called myData, we then run the hist function and pass in myData. This will generate this histogram here. Another example here, we have a pie chart. Okay, and again, we have a vector called myData, and all we're doing is running the pie function and passing in myData, and this is coming out here. Okay, now here's a file that you won't often hear about these days. This is a file called a dat file, a data file. And we have a dat file that has 3 columns in it, cars, trucks, and SUVs. Okay, and we can run a creation command and it will generate the 3 lines here and include a legend as well. And another type of plot, another example we have is a bar chart. And so we're going to pass in that dat file that we created, and then we're going to run the bar plot function. We're going to pass in the autos dat file, provide a main, a Y label. We're going to say that we want rainbow colors, and we're going to add a legend. All right, and I think I've actually just slightly cropped out the legend there. So that's just an overview of some of the basic functions that we can run with R. I've added a list of resources here that you can go and have a look at. So we have a large list of charts here. Let's have a look. And this is sites.harding.edu. There's where I got those autos examples from. And this can show you how to develop the scripts into something a little bit more detailed. Okay, here's a dot chart. And there's a little some examples that show you all the different symbols that you can get. Okay, SW Carpentry is quite a good website, and this has a very large tutorial on R, and literally it is a huge tutorial of how to do lots and lots and lots of things. Okay, and then I have a website called Kaggle. Now Kaggle is, let me just show you. It's a website that's largely designed around data science. And in Kaggle, people have done all sorts of analysis on different data sets. So if we were to go to compete, they actually have competitions on who can analyze different types of data sets. So let's have a look and see if we can find one that might be moderately interesting. There's one about hungry geese. House prices, advanced regression techniques, Titanic, machine learning from the disaster. Let's have a look at this one. So there was a Titanic data set, and here's a video and someone talking about it. So there was a challenge. The challenge, they were going to build a predictive data model that answers the question, what sorts of people were more likely to survive on the Titanic? All right. And so this would take through kind of what's happened here. Let's have a look at the see if we can see some let's look at the leaderboard. The leaderboard is calculated. Okay, so this person is in the lead. Entries 2. I wonder if we can see their entry. Have a look at the data sets. Titanic, maybe notebooks. See if we can see some examples. Titanic to beginner. Okay, let's have a look. See what this chap's done. So here we're got some examples of okay. So here's the kind of examples of survivors of kind of the data sets. Now, if we go on to Kaggle and click data, there's all sorts of data sets available now that people are analyzing. One of the more humorous ones is an analysis of Trump's Twitter insults, and they've carefully been collating his information, but obviously I think he's been like fully banned off of Twitter now, so I don't think that they can continue this analysis. But if we look into his they've done hundreds and hundreds of tweets and analysis. Like there's 581 kilobytes of data in here, and there's all sorts of analysis. Let me just have a look and see if we can have a look at some. So there's a Trump insult analysis. Let's just have a wee look down and see what sort of, there we go. Look, fake news seems to be his main word. There's someone's created a fake news and witch hunt seem to be his two most, oh, look at that. Someone's created a word cloud in the shape of his head. And his main thing that he talks about is fake news. Okay, so there's all sorts of things available on Kaggle. I've put a link to where to download R for R installation, and I've also put a link there to download the desktop edition of R. And hopefully that information there should help with Lab 1. And let's have a look at Lab 2 now, which takes R into a little bit more detail. So in Lab 2, we're going to look at a data set called MTCars. Now, MTCars stands for Motor Trend Cars. And here's a little quote from various people that I've worked with who said, why don't you use more realistic data sets? Stop teaching people about cars from the 70s. Stop speaking about automatic versus manual transmission. Give them a data set that they can relate to. So that's the kind of feedback that I get. But I say, forget that. Forget the naysayers. Let's look at MTCars. Okay, it's quite common on the internet for people to be like, are you sick of looking at MTCars? How can you be sick of it if we've never looked at it? So today's your lucky day. So for Lab 2, we're going to look at MTCars. Now, what MTCars was it look like? It's a 1970s car magazine. Okay, it looks a little bit like this. Right. Later on, we're going to look at this iris data set as well, but let's just explain what we have in MTCars. So quick scan of Lab 1 again. Lab 1 starts off with installing RStudio, different instructions for different operating systems. Then we do some basic plots, fill out the ePortfolio, and we should be all good. Now, the Eportfolio template is available on the Moodle. All you have to do is check the Moodle page and see what requirements there are and add that to the ePortfolio template for that week. So hopefully week 1 should provide a good introduction. Let's look at week 2. So I've put a little bit of sort of interesting justification as climate change becomes an ever more real threat to the Earth, with a capital E. In the minds of leaders across the world, many governments are taking action to mitigate greenhouse gas emissions. The automobile industry in particular is targeted for regulations. So let's have a look at some old automobiles. We can call this data set in RStudio by running data MT cars. So let me just run this now. Let's just go environment here. Let's go plots. Let's clear this with Control L. And up here, let's do, actually, we'll just run it in the console. Data, okay, MT, and see, look, it's already suggesting to me, it's hinting to me what we want. So there we go, MT cars. Right. Now, let's just run the help function on the MT cars dataset. Okay, if we run help, it's going to give us a description, and it's going to say down here, and let me just jump across to this and make it a bit bigger. The data was extracted from the 1974 Motor Trend US magazine and comprises fuel consumption and 10 aspects of automobile design. Okay, so once we've got so just to say as well, MT cars is built into RStudio. That's why we're using it. Don't worry, we're not importing a 1970s car database for no reason. It's already there, and that's why we're going to use it. So if we want to see the top of the data set, we can run the head command, and this is just how many lines we want. Okay, so let's do heads, okay, MT cars, and comma 3, and that'll give us the top 3 lines. Right, so we can see that inside the MT cars dataset, in column A, we have different cars, Mazda RX-4, Mazda RX-4 wagon, the Datsun 710, and then we have miles per gallon, number of cylinders, horsepower, AM stands for automatic or manual transmission. Gear is the number of gears that the car has. All right, there's an explanation of this in help when we run each of these. So for example, disp is the displacement in cubic inches as shown over here in the help. So can you see the first line? How many mpg was the Mazda MX-4? Hopefully you can answer that. Right, so then what we're going to do is we're going to run some commands on this to create some plots, and we're going to develop these into slightly more elaborate plots with some more commands, and then just a bit of a review of what we did. And then in the second part, we're going to look at the iris dataset. Now the iris dataset is also quite famous, and it's different from MT cars. It's a flower dataset that was created by a biologist called Ronald Fisher in the 1930s, and it's also built into our studio for us to use. And you can do all sorts of analysis. And if you don't know what an iris is, it's a flower, and there's some pictures of some irises there. So that's the iris dataset. So again, in RStudio, if we did data, okay, and then we opened up our, and we did iris, and run that, okay, and then we do help, iris, okay, over here we're going to get some information about the iris dataset there. Okay, so the latter part of the lab is just looking at some stuff in summary about the iris dataset. And then what we're going to do is we're going to create a histogram, and we're going to look at how we install a package called ggplot2. This is a famous plotting package. And then we're going to create some of these plots here. Now, once we get to the end of lab 2, on the Moodle, we should have some requirements for the ePortfolio. So for each week, what we want to do is we want to download the ePortfolio template. Okay, open up the ePortfolio template, and then we just want to add our name here, okay, and fill out the weekly summary for each week. So for lab 1, we would put the lab 1 title here, the day, month, and year, and just add in the requirements. And those requirements will be listed on the Moodle each week. So for lab 2, for example, let's say I want to add in my evidence for the ePortfolio for lab 2. Okay, I'll get the title of the lab, which is Common R datasets. So I would just change that to Common R datasets. I'd put the date that we did this in. I'd then go and check the Moodle and see what was required for that week. So if we scroll to this week, we have what we want to do. And what we want to do is take a screenshot of running part 1.4, add an image of another histogram, and add an image. So we add those to the ePortfolio. We then export that as a PDF and upload it to the Moodle link, and we can add that as evidence. So this week we have 4 tasks to complete and upload. So that's lab 1, that's lab 2, that's an introduction to R. I think I should probably stop there and let everyone get in and get started and have a go. I mean, I'm very much a supporter of the idea that you learn by doing. Okay, so in the kind of early 2000s and in the 90s, there used to be a theory that there were different learning styles. Some people learned by reading, some people learned by writing, and there was one that they talked about called learning by doing. But I don't necessarily know if that's true. I think that the best way to learn is to actually go ahead and do something. So obviously I'm not an educational psychologist. That's just my opinion. So any questions you have, you can post them into the Teams, and good luck.